Let's talk about a huge but kinda invisible shift happening in the world of AI right now. It's all about a change of address for where AI actually does its thinking. And believe me, it's getting way, way closer to home than you might imagine.
So think about it for a second. When you ask your smart speaker a question, or when you're scrolling and an algorithm perfectly recommends a video, where is that AI? Where does it live? You probably think, well, it's in the cloud, right? Some giant, far-off data center.
And you'd be right, for now. But what if I told you that very soon, the AI that's powering your digital life could literally be running in a building right down the street? Yeah, inside your local internet provider's office. Look, this isn't some far-off sci-fi stuff. This is a massive change in how the internet is built, and it's already happening. It's all being built on top of a foundation that the tech giants have been quietly putting in place for years. Here's the wild part. The plumbing is already there. For a long time now, companies like Netflix, Google, and Meta have been physically placing their own servers, these things called caching servers, directly inside local ISP buildings. It's the secret sauce for why your Netflix show or YouTube video starts instantly. They've already stored the popular stuff in a building that's super close to you. And that network of local hardware, well, it's the perfect launchpad for what's coming next. It's a concept called edge inference. It sounds technical, but all it really means is running the AI calculations, the inferences, on those local servers at the edge of the network, instead of making that long trip back to a central data center.
Okay, but why? Why go through all the trouble of moving AI out of these super powerful centralized data centers? Well, it really all comes down to one thing we can all understand: the need for speed.
Just think of it like this. The old way is like your data has to take a long road trip to some massive superstore halfway across the country. Your request travels hundreds, maybe thousands of miles, gets processed, and then travels all the way back. The new way, it's like walking down to the corner shop. Your request just zips over to that local ISP building and comes right back. It's a much, much shorter trip. And we're talking about shaving off about 20 to 40 milliseconds from that round-trip time. Now, I know what you're thinking. A millisecond? That's a thousandth of a second. Who cares? Well, in the world of computing and AI, that's an absolute eternity. Seriously, think about the applications. For augmented reality, where digital stuff has to be perfectly locked onto the real world in your glasses, any delay makes you feel sick. For a real-time translator whispering in your ear, or a truly smart AI character in a video game that reacts instantly, that speed is everything. That tiny 40-millisecond difference is what separates a magical, seamless experience from something that just feels clunky and broken. So really, this whole enormous shift boils down to three big pressures. You've got latency, which is that need for speed we've been talking about. Then there's bandwidth. By processing things locally, you stop clogging up the internet's main highways. And finally, there's cost. It's just way cheaper to run a million tiny AI jobs locally than it is to constantly ping your most powerful, most expensive central brain. And of course, whenever there's a valuable new piece of internet real estate up for grabs, you know who shows up. This shift is creating a brand new battlefield, and the tech giants are already fighting to control this new territory at the edge. And each of the big players has its own unique superpower here. You could argue Google is the most ready with their own custom AI chips, their TPUs, and of course, the entire Android ecosystem. Meta has the ultimate reason to do this, their AR and VR devices, which absolutely will not work without this kind of low-latency AI. And then there's Netflix, which has a massive head start because they're already physically inside all these ISP buildings. They're perfectly positioned to run models that optimize your video quality on the fly. Now, this doesn't mean those giant city-sized data centers are going away. Not at all. Instead, what we're seeing is a new structure for AI emerge. Think of it like a pyramid with different layers of intelligence. So here's how this new pyramid is shaping up. Right at the bottom, on the device in your hand, you've got tiny little models for simple tasks. One level up, you've got those ISP edge servers handling the small and medium models for all that real-time stuff. Go up another level, and you've got regional data centers with larger, more powerful AIs. And then right at the very top, in the centralized cloud, you have the absolute monsters, the frontier models, the most powerful AIs on the planet. The whole system will be smart enough to send your request to the right layer for the job. Okay, so this is all really cool from a tech perspective, but let's get down to it. What does this new world of distributed AI actually mean for you and me in our daily lives? Well, for starters, your local internet provider is about to become a way more important company because they'll be hosting all this critical AI gear.
We're also going to see an absolute explosion of new apps that just weren't even possible before, things that depend on that instant AI feedback. On another note, it could also make things like local data privacy laws much easier to enforce, since the data can be processed inside a country's borders. But the big takeaway is this: it's all leading to a digital world that just feels smarter, faster, and way more responsive.
And that brings us to the final and maybe the most critical question. In this new, layered, distributed world, who's actually in control? Where does the real power sit?
The answer lies in something called the inference routing layer. Think of this as the master brain of the entire network. It's the software that looks at every single request you make and, in a split second, decides, okay, should this go to the little local model down the street, or does this need to go all the way to the giant brain in the cloud? It's the traffic cop for every single AI interaction on the internet.
So that leads us to the ultimate power play. Who owns the inference routing layer? Because whoever controls that layer, whoever gets to decide where your data goes and which AI gets to answer you, that's who will hold an unbelievable amount of strategic power over the next chapter of the internet. It's the next great tech battleground, and it's happening right under our noses and, well, right down the street.